So that leads to another topic of condition monitoring. Normally, we refer it as a permanent monitoring for the power apparatus in the towers and the substation. So the condition monitoring, the system configuration, or if we're talking about the sensors, sensor installations, that will be quite similar as online testing. So if we're talking about the cables, we use HFCTs. If we're talking about transformer switch gears, we have some other sensors that we can use. And the data acquisition unit, we put it close to the platform or close to the sensor, to the equipment under test. And the data acquisition unit can be interconnected by the fiber optics, which might be some challenge for the offshore wind farms to access to the fiber optics. And the central server, it can be installed on the platform or in the service room. It will be a rack with the server, with the power supply and watchdog and the UPS to support the central server. And apparently, the central server can be accessed remotely as long as it's allowed by the customers. So that's a general configuration of the monitoring system. The sensor installation, we can install the sensors. This is an example of the sensor installation to monitor the entire the wind farm, monitor the entire wind farm. So we don't have to install the sensors in every tower. We can install the sensors in every other tower. In that case, we can still cover all the cables, switch gears, cable accessories. So here is the example. The red circle means that we have a acquisition unit to monitor 6 channels. For example, if we're looking at it here, there's a cable coming in and there's a cable circuit coming out. So two circuits, 6 channels for the acquisition. For the blue circle monitors 9 channels, 3 circuits, 1 coming in, 2 coming out. And for the black one is it's more like a junction box. So here we only require to put 3 channels of PD acquisition to monitor one direction. So with that configuration, we can monitor the entire wind farm. And as I said, the data acquisition system can be connected by the fiber optics. And we can put the central server in the service room somewhere around the facility. And this is the example of the data acquisition unit. This is the PD scope, which is with the same series as the Aquila that we're talking about, the portable equipment for the commissioning and the maintenance test. So the hardware, the core is the same. The PD scope itself has 3 channels, and it can be expanded to 6 channels with a additional device called a multiplexer. And one device can measure 2 circuits. And the central control unit, it has the server, it has the watchdog, and it has the switch to measure different units. Right, so that's the central server. Central server can be connected to all sorts of monitoring component. Here we're talking about a PD measuring unit. It can also be connected to some other diagnostic markers. If we have temperature monitoring, we can also connect to the central server. If we have the transformer monitoring, like a DGA or 10 delta monitoring, we can also connect to the server. And we have our own SCADA system that can use to store, monitor, and display all the components within the network. If the customer has its own SCADA system, it's fine. We can merge our system with the customer's SCADA system. We can provide the connections, the communication protocols like the Modbus, NDP3 or some other standard for the communications. So the condition monitoring for transformers is a little bit more complicated. Besides the PD monitoring, as we mentioned, if we use tab adapter, we can also monitor the 10 delta and the change of capacitance. Another thing that most of the transformer monitoring will use is the DGA, dissolved gas analysis. So dissolved gas analysis, in the typical configurations, we provide carbon monoxide and the hydrogen gas indicator for the thermal faults or PD and electrical discharges. All the monitoring solutions are highly customized. So the two gas DGA analysis is our typical offering. So I know some customers, they prefer to have more advanced DGA analysis, which is fine. We can easily change our DGA unit to 7, 8, or 9 gas analysis component. So as I said, all of those are very flexible and can be customized. So here's an example of the transformer monitoring. We have the tab adapter with some component called the TD box. So TD box basically it extracts the information from the tab adapter and split into the PD signals and the 10 delta signals. One is high frequency, one is low frequency, basically. So with the TD box, all the things will be merged into the TD multiplexer that will collect and extract all sorts of informations. The DGA, I believe DGA is not included here, but DGA is here. So DGA also has its signal going to the TD multiplexer, providing all those informations. And also, in the meantime, we can have thermal and humidity sensor to measure the temperature and humidity. So those are all the low frequency signals that can be included in the monitoring system. So again, the central unit can talk to the data acquisition unit. The data acquisition unit can be installed next to the tower or next to the platform and finally communicate to the central unit. So the SCADA system, that's what we said. SCADA system, if the customer doesn't have the SCADA system, we have our own system that we can implement it in the central unit. If the customer has its own SCADA system, we can provide the standard communication protocols and merge our monitoring data to the customer existing SCADA system. So there's some example of the Techimp SCADA system. I'm not going to talk too much of details, but everything is very flexible. We provide a couple of packages so that for different applications. So if the customer has a lot of equipment that needs to be monitored, we can build the diagnostic package, or we can build different options to set up the alarm, set up different algorithms to store or to alert the users. So everything is very flexible. So conclusion, we've been talking a lot of information here. I'm sorry, it took a little bit longer time than we expected. So in general, we go through the fundamental PD testing technologies and the uniqueness of Techimp PD testing technologies. And in the application of wind farms, we provide such 3 levels of assessment, commissioning, monitoring, and maintenance services to ensure that we can do the assessment for each individual power apparatus for the wind farms and to ensure great reliability and good performance for your wind farm apparatus. Okay, I think that's it. Thank you everyone for coming, and Thank you very much for your time and for your attending